Hello and welcome to a discussion on linear inequalities. These are two variables in an inequality that can be written in these four terms, where a, b, and c are real numbers and a and b are not zero. Okay, ordered pairs of solutions to the inequalities. To determine whether or not an ordered pair is a possible solution of the linear inequality in two variables, plug the x and y values into the linear inequality. If the inequality is true, then the ordered pair is a possible solution to the inequality. However, if the inequality is false, then the ordered pair is not a possible solution to the inequality. So let's look at some examples and let's see what we can do with these. Alright, so we're given the inequality y minus x is greater than 3. So we're given these two pairs. So let's test out where y in this case is going to be equal to 7 and x is going to be equal to 3, because this is what this ordered pair tells us. So we'll take our equation, y minus x is greater than 3. Let's plug in these values, 7 in for y, minus 3 in for x, greater than 3. If we solve this, we see 7 minus 3 is 4, greater than 3. Is that a true statement? It is, because 4 is greater than 3. So that means that 3 comma 7 is a solution, is a possible solution to the linear inequality. Now if we take a look at negative 2, negative 1, that means x is negative 2 and y is negative 1. Taking our equation, y minus x is greater than 3. Let's plug negative 1 in for y, minus a negative 2 in for x, greater than 3. So if we simplify, we have negative 1 plus 2, because of these two minus signs, greater than 3. So if we simplify even further, 1 is greater than 3. And is that a true statement? That is not. So that is not a possible solution. That made the inequality false. Okay, we look at our next example. We have the coordinate pair 1 comma 4 and 3 comma 3 for the equation 3x plus y is less than 9. So if we plug in, let's see what we can do. So for this, what I did was rewrite the equation but leaving x and y as parentheses. Now I'm going to take the x and y values from the coordinate pair and plug these in. So x is going to be 1, so there was x in the original one, and y is supposed to be 4, so I'm going to put 4 where the y was in the original equality. Now to simplify, 3 times 1 is 3, plus 4 is less than 9. Okay, 3 plus 4 is 7, less than 9. And is 7 ever less than 9? It is. So that is a true statement. That means that ordered pair is a possible solution to the inequality. Okay, now I'm going to write this part down here. We have 3 comma 3 as the coordinate pair. So rewriting the equation, replace x and y with parentheses. Let's plug a 3 in for x and the 3 in for y, as they appear in the original equation. So 3 times 3 is 9, plus 3 is less than 9. So if we add 9 and 3, we get 12. And is 12 less than 9? It is not. So that is not a possible solution. Because it made the inequality into a false statement. Okay, looking at this example, we have 2x minus y is greater than or equal to 3. So let's take our original inequality, replace the x and y with open parentheses, and then we'll just plug in. Here was x, so we're going to replace it with a 2. And here was y, so let's replace it with a 1 according to this coordinate pair. If we simplify, we have 2 times 2 is 4, minus 1 is greater than or equal to 3. 4 minus 1 is 3, is greater than or equal to 3. And is this a true statement? It is a true statement because of this inequality sign, right, or this equals part of the inequality. That makes that a true statement because 3 is equal to 3, but 3 is not greater than 3. Okay, if we look at the next coordinate pair, we have negative 5, comma 1. So let's take that coordinate pair. We have our original equation replacing x and y with open and closed parentheses. So where x appeared in the equation, right here, we're going to place a negative 5 in, and then 1 in for y. Going through and simplifying, we have negative 2 times 5 is negative 10, minus 1 is greater than or equal to 3. So we have negative 10 minus 1 is negative 11, greater than or equal to 3. And you have to ask yourself, is that a true statement? And that is not. So that is not a possible solution. And finally, for our last example, we have 5y minus 4x is less than or equal to 14. So let's take a look at these. At writing our original inequality, but replacing x and y with closed parentheses, open and closed parentheses. So where y appeared was right here, so let's replace it with a 1 according to the coordinate pair, and x appeared here, so let's replace it with 2. Right, now let's go through and simplify. 5 times 1 is 5, minus 4 times 2 is 8, less than or equal to 14. So we have 5 minus 8 is negative 3, less than or equal to 14. And is this a true statement? Yes, because negative 3 is less than 14. Okay, now if we look at the next coordinate pair of 5, 2, let's replace our original inequality variables with open parentheses. So y appeared right here, so let's replace it with a 2, and x appeared here, so let's replace it with a 5. Okay, solving, 5 times 2 is 10, minus negative 4 times 5 is 20. It's less than or equal to 14. So 10 minus 20 is negative 10, less than or equal to 14. Is it a true statement? Yes. So that means both of these are possible solutions to the inequality set.